After studying this module, you shall be able to know what is economic impact assessment, that is EIA of a project, learn the tools and methods of EIA, identify the best available project to be undertaken, and evaluate alternative projects based on cost benefit analysis, and then analyze cost benefits, project targets and outcomes. Introduction. The prime objective of project economic appraisal or analysis is to help design and choose projects that enhance welfare of a country. The role of economic analysis is to answer questions about the impact of the project on the agency undertaking the project, on economy and on different stakeholders. Economic impact assessment lays out the risks associated with the project and its sustainability. In particular, the tools of EIA help in the following: to decide whether the project should be undertaken by the government or by a private entity, to estimate fiscal impact of the project, to determine ways of cost recovery and effectiveness, to assess social and environmental impact of the project and its contribution to distributional and welfare objectives of the society. Now, what are the steps taken in economic analysis? Let us first define the objective of the project. The first step of a project involves identifying and defining the objectives of the project. Clarity in definition is of paramount importance to select the tools of analysis and indicators and outcomes that would define success of the project. The range of objectives that are chosen for the project determine the tools of economic analysis. For example, if reduction in costs is objective, then comparison of different cost benefit ratios of alternative projects might be adequate. If the project's objective is to improve status of health, then the alternative interventions have to be compared on the basis of the impact on health status. In essence, clearly defined objective is essential to determine the set of feasible alternatives to obtain the desired result. Defining the counterfactual. The most fundamental question to be answered is that of defining the counterfactual. That is, what if the project is undertaken versus what if the project is not undertaken? How to gauge the impact of the project across groups in the society? The difference between the situation with and without the project is the basis for calculating the incremental costs and benefits of the project. Is the project the best alternative? After having defined the counterfactual, another important issue concerns the examination of alternatives. What are the plausible alternatives to the project? What is the basis of difference among alternatives? Do they differ on the basis of technical specification, policy, or institutional reforms, beneficiary locations, financial arrangements? Repeat, or do these differences are scale and time variant? How would the alternative achieve the same goals under different costs and benefit structure? Does the project have separable components? Some projects can be undertaken in isolation, while others call for an integrated package. This has very important implications for cost and timeline. For example, a power generation project to be successful has to be accompanied by transmission and distribution facilities. Project's impact and fiscal situation and financial sustainability of the project. Cost recovery is important to maintain fiscal balance for macroeconomic stability. The implications of project on public expenditure and revenue need to be assessed. Cost recovery may also be different in terms of losers and gainers of the project. Distributional equity needs to be kept in mind while doing project analysis. Cost benefit analysis. Identifying costs and benefits. The next step involves identification of costs and benefits. This needs the calculation of projected costs and benefits. However, not all costs and benefits need to be included. Also, it is required that the social opportunity costs of the projects be evaluated. Economic analysis, therefore, must take a holistic view of the project in terms of its impact on the entire society. Cost benefit analysis of a project has three components. 1. Estimating the net impact of the project. The first step requires analysis of two main aspects. First, what outcomes have the project participants achieved in comparison of a situation in which they had not participated in the project, that is, the net impact of the intervention. Second, any scale up of the project to include more beneficiaries would result in the same net impact or not. Tests of significance are used to calculate the size of the estimated net impact. In a large representative sample, tests of significance will tell you whether a random selection of another group of participants from the same population will have the same net impact under the intervention. To do this, a control group has to be set up against the treatment group where the former are not provided the intervention while the latter are in treatment. Estimating the social costs and benefits of the intervention in monetary terms. The second step in conducting a cost benefit analysis involves an estimation of the social costs and social benefits of the intervention in monetary terms. Estimating benefits needs to be carefully done as a project is bound to have short run and long run benefits as well as direct and indirect benefits. Similarly, while identifying beneficiaries, there are direct and indirect beneficiaries. Though very long term benefits may not be measurable, it is worth considering intermediate milestones. Costs also need to be estimated in terms of fixed costs, variable costs and funding costs. It is rare for the cost of intervention to extend beyond the intervention period. If they occur, they will in most cases be revealed as negative benefits and will be monitored through the benefits section. Calculating the cost benefit. Cost benefit analysis provide a single measure, which is a summary measure of the difference between the costs and benefits of an intervention. This is the net present value, a preferred method to calculate the net impact of a project. Some prefer to calculate difference between net costs and net benefits. Present value calculations can be measured at any time even after the project has ended. Cost effectiveness analysis, often called CEA. As compared to cost-benefit analysis, cost-effectiveness approaches are used when the projected benefits cannot be converted into a comparable monetized measure. This investment criteria ranks alternative projects in terms of costs. The investment decision criteria aims to minimize the new present value of costs. The cost effectiveness rule is considered a better decision rule only when the benefits accruing from different alternatives are homogeneous. It would be appropriate then to use this rule when comparing two or more projects. In the case where interventions have multiple types of benefits, then the cost effectiveness approach cannot be used. In that case, the net present value and rate of return formula are preferred. In general, the CBA and CEA will give different rankings depending on the choice of discount rate as well as the time period under consideration. Measuring spillovers and externalities. Projects have several unintended spillovers or externalities. These are unintended effects, positive or negative, of the projects on a third party. Generally, the third party has no power over the absorption of these effects. Spillovers are always non-marketed and cannot be measured using the price mechanism. Sometimes the extent and spread of externalities are huge and varied across time and space. In this case, project appraisal needs to consider more immediate externalities. Let's look at the costs and benefits. Identification of costs and benefits. The following need to be addressed while identification of costs and benefits. 1. System costs. A particular project investment could call for complementary investments. For example, a power generation project has to be accompanied by transmission and distribution. Hence, all the related costs that are part of the system need to be considered. 2. Sunk costs. Sunk costs of the project need not be included in the project costs. Contingencies. These have to be treated as part of project cost. Working capital. This is defined as net receivables, market securities, bank balances and cash on hand. For economic analysis, only real resources need to be considered. Transfer payments, taxes, subsidies and duties are not to be included. Depreciation. Economic analysis does not include depreciation provisions, while expenditures on repairs and maintenance need to be taken into account. Depletion premium. In the case of non-renewable resources, depletion premium should be included to arrive at true economic cost. Externalities. Project effects, whether positive or negative, do not get reflected in the financial analysis. Whenever these externalities are large, they have to be considered in economic analysis. Valuation of non-market costs and benefits. Choice of discount rate. Since externalities have non-marketed costs and benefits, values for these need to be imputed. Calculation of appropriate social discount rate. which is also called SDR, is crucial to CBA. A too high SDR could prevent socially desirable projects from being undertaken, while setting it too low could imply choice of inefficient investments. Under perfect conditions, without market distortions, SDR equals market interest rate. Since the market interest rates do not reflect marginal social opportunity cost of investment, the issue then is to find out what rate should be used to discount future costs and benefits. Economists have proposed different approaches of SDR calculation. Difference accounting on account of effect of public investment on domestic consumption, private investment and cost of international borrowing. The following are the main ways to discount future. Social rate of time preference, called SRTP. This is the rate at which society is willing to trade 1 unit of present consumption for future consumption. One way to do this is to use after tax rate of return on government bonds. This could lead to lower rate of discount, as society would have a bias towards lower rate in its collective attitude. The other method is formula based on growth model. SRTP, which depends on utility discount rate reflecting pure time preference, elasticity of marginal utility of consumption and annual rate of growth of real consumption per capita. Marginal social opportunity cost of capital, called SOC. Merlis and Baumol and others propose the use of SOC based that both government and private sector compete for the same scarce resources available to an economy. Therefore, both should yield same returns. Weighted average approach. Using SRTP as discount rate leads to the omission of impacts of public projects on funds available for private investment. Using SOC, on the other hand, falsely assumes that public investment only displaces private investment and not consumption. The weighted average reconciles the two approaches. This, however, leads to over-discounting of project benefits, leading to a bias against long-term projects. Shadow price of capital approach. Proposed by Feldstein in 1972 and Bradford in 1975 and Lind in 1982, among others. This recognizes that the total cost of a public project is a sum of present consumption and future foregone consumption streams. Similarly, for benefits, net present value of projects is calculated by discounting future costs and benefits. Discounting intergenerational projects. From the mid-1990s, among growing issues of global warming, climate changes and environmental problems, intergenerational equity concerns have become important considerations. Economic prices of traded goods and services. Changes in price due to a project affect the demand and supply of goods and services in the economy. These effects should be accounted for in a project evaluation. Economic prices of non-traded goods and services. The marginal cost and prices may differ significantly in the case of non-traded goods. For example, peak load power or railway tariffs, etc. Shadow prices or wage rates. Labor is one of the most important components in projects, and the market for labor is generally distorted in developing countries. Differences occur in types of labor like skilled, semi-skilled, rural and urban labor. In determining the economic price of labor, both the level of skills and location of project need to be taken account of. Comparing costs and benefits, that is an investment criteria. After identification and valuation of costs and benefits of projects, the next step requires comparison of projects. A project should have a net positive benefit, and this should be larger than in other alternative projects. Comparison of costs and benefits can be done using the following. 1. Economic internal rate of return, rate of discount at which the costs and benefits are equalized. Or cost benefit ratio, which compares present value costs and benefits by discounting them at rate equal to opportunity cost. Net present value, which is a difference between the costs and benefits. Sensitivity test. The next step involves carrying a sensitivity test. This indicates how a possible change may affect a project's economic viability. The sensitivity indicator measures the sensitivity of the economic internal rate of return, which is called EIRR, to changes in the main variable. Project risks. Lastly, the project's risk need to be assessed and minimized. Risks vary for different projects and are inherently greater for projects. The EIRR is marginally higher than opportunity cost of capital. Summary. Let us summarize. In this module, we learn about steps and aspects of project economic analysis. We can put this in a box. Box 1. Public intervention, that is rationale and examples. Different interventions are needed depending on the market failure that exists in the system. Some of these are enumerated below. 1. Natural monopoly calls for some kind of regulation provisions. For example, water supply and electricity from natural monopolies. These can be tackled by franchise bidding. 2. Externalities can be taxed or subsidies, like in the case of pollution control and education. 3. In case of public goods, when exclusion is difficult, like rural roads and public health, an intervention calls for provision of these. In case of situation where exclusion is undesirable, like research and extension, intervention could be one of the provisions of subsidies. 4. Information failures or incomplete markets call for regulation, taxes or subsidies, like in the cases of rural development, farmer credit, capital markets and insurance. Table 1. Sector specific guidelines for project economic analysis. Let's have 3 roles: project component, sectoral objective, steps in EIA. Under this, education project, providing knowledge, skill enhancement, equal learning opportunity. And in the 3rd row, need assessment of project, identification of target groups, its location, income social status, assesses financial need, assess budgetary implication, assess distributional aspects, comparison of costs and benefits, private versus public education. Again, in case of health sector project, prevention or control of diseases, improved health status of children and women, creating health awareness. And in the third row, review of macroeconomics, considerations, review of healthcare system, national health plan, justification of sectoral needs, review of efficiency considerations, cost benefits analysis by use of cost effectiveness analysis and internal rate of interest, demand analysis, assess sustainability of project, equity considerations, access to facilities, affordability of intervention, cost recovery aspects. Table 2, urban service improvement, estimation of economic benefits. Again, we have 3 rows: component, method and tools. And respectively, we'll talk about transport. In methods, savings of travel time and operating costs, accidental and environmental cost, statistical value of life, contingent valuation approach, and under tools, cost benefit analysis. Similarly, in case of river improvement, resource cost saving, environmental costs, displacement and rehabilitation cost, and in the third, cost benefit analysis, water supply, contingent valuation, cost of illness, hedonic prices, and then in the third, cost benefit analysis. Box 2, economic impact assessment of project. The main areas to be covered are macroeconomic assessment. That is, what are the macro policies that affect the project? How are the project's outcomes and targets affected by macroeconomic scenario? Analysis of key projections and economic outlook. Sector assessment. What will be the sector performance? What are the implications of the project for institutional and ownership performance and structure? How will the project fare in the prevailing policy environment? What are the constraints on sector performance, market and non-market failures? Demand assessment. What is the demand for the project? What are the users willing to pay for the use of services of the project or for project implementation? In case of losers from the project, what is the willingness to accept? Analysis of demand in a sector by estimating the main factors that influence demand. Economic rationale. What is the justification for undertaking the project? Why is public intervention necessary? Do the non-market or institutional failures justify institutional and policy reforms? Need to address market or institutional, role of private sector and rationale for public sector involvement. How does the project meet the national development goals or plans of the country? Project alternative analysis. Need to identify the counterfactual, comparing with and without project scenarios. Assessment of project alternatives in terms of scale, technology, location and timing. Least cost analysis as basis for project selection. Cost benefit analysis. What are the projected benefits and costs of the project? Do benefits outweigh the costs? Estimation of benefits and costs among alternative projects using cost effectiveness analysis wherever needed, choosing price level for shadow pricing, estimating net present value and internal rate of return for each part of the project and the whole project. Financial and institutional sustainability, assessment of need for resources and source of funding for projects, ensuring a steady flow of funds to maintain flow of project benefits, estimation of financial return of the project, implication of project for taxes or subsidies, assessing the fiscal impact of the project, distribution analysis, finding out the beneficiaries of the project and assessing the benefits accruing to them, identification of the main project stakeholders, assessment of benefit incidence, identification of key target groups of project, risk and sensitivity analysis, assessing risks of the projects, identifying the key project parameters, quantitative risk analysis based on probability distribution for key variables, assessment of institutional risks, identification of measures to monitor and reduce project risk, monitoring and evaluation, evaluating the project on the basis on project outcomes and targets.